Alrighty, hello everyone. My name is Erin, and today I'm going to be talking about kin recognition mechanisms in animals and the kin selection theory. So if you can see behind me, there is a lovely flamboyance of flamingos, and to you and I, they may all look the same, but to each other, they're able to differentiate between each individual. So how are they able to do that? Well, it's because they have evolved a series of mechanisms to be able to do this. I'm just going to call them kin recognition mechanisms, or it's the ability to recognize kin. And pretty much every animal has this. Anything from bacteria, sponges, sea anemones, jellyfish, humans, other primates like monkeys, pretty much any animal that you can think of are going to have these mechanisms. Just because if you are an animal, and we are, it's very helpful to, sorry, these are really loud peacocks over here, but it's going to be really helpful for groups of organisms living together to differentiate between each other so that they can prevent inbreeding, maybe maximize inbreeding, which sounds kind of contradictory. Or they could help facilitate nepotism. So if you're able to identify kin and organisms that you are related to, you're going to be more likely to help them out and you can better assist them. So how can you do all this if you don't have kin recognition mechanisms, right? So that's kind of like the evolutionary origin of these mechanisms, of which there are 4 main mechanisms that I'm going to talk about today. Each of them can specifically deal with, think of like sensory systems. So your sense of smell, taste, touch, your auditory sense, so hearing, and olfactory sense are going to be really important in being able to identify kin. So back to those 4 mechanisms, it's going to be spatial distribution, association, phenotype matching, and recognition alleles. So spatial distribution and association kind of go hand in hand together. These are just when organisms are... Now 4:30 and the zoo gates will be closing in 30 minutes. Sorry about that. So this is going, spatial distribution. Alrighty, apparently I did something to make those monkeys really mad, so sorry about that. But spatial distribution and association are going to be, basic premise is if an animal runs into the same animals over and over again, then it's going to assume that they're going to be more likely to be related to them. So if you see the same individual every day, you're just going to assume, okay, I'm probably related to them in some way, so probably not going to breed with them or anything like that. And then association can also be really well described by like nest mates. If you think of animals that are born in a nest, they get to associate with their siblings in those first few weeks or months, and so they have a really firm basis of knowing who they're related to, and they're going to remember that for the rest of their lives. Primarily through the olfactory sense, so they get that sense of smell. And then phenotype matching is really cool. Humans use it a lot, whether you know it or not. It's basically when an individual compares other individuals based on a template they created. So like humans do it through facial recognition. So if you think about anytime you walk into a room and you're looking at a bunch of people, you think, oh, well, that person looks like maybe my friend, or they look like me. Then you're kind of indirectly performing kin recognition. So humans do that a lot. Other primates also do that a lot. But it's basically just creating that template and comparing it to other individuals. And based on that template, the level of recognition is implied. So this is also a really good example for twins. So I'm a twin, and a lot of people, when they see me and my sister, they're like, oh my gosh, you look so alike. And that's because they can look at us and compare our facial structure and see the similarity between us. By contrast, I also have a little sister, and no one thinks we're related at all because we just don't look alike. So people are using it all the time. And then the last recognition mechanism is the use of recognition alleles, which go hand in hand with phenotype matching. It's basically a genetic explanation for phenotype matching. So there's like specific genetic code in every organism or us that allows for phenotype matching, and a lot of people don't like that recognition allele explanation because it is extremely hard to prove and nobody's done it yet. So essentially people are saying that there could be genetic basis for phenotype matching, but nobody knows for sure. But it is one of the theories out there. I've got a very loud peacock behind me. So if you have all these recognition mechanisms, what are they for? Well, I've kind of mentioned before, it's to reduce inbreeding. That one's pretty obvious. You gotta know who you're related to in order to avoid those detrimental inbreeding effects. But then you can also maximize inbreeding, which is when you breed far enough away in the genetic line that you will avoid those detrimental effects, and then also gain kind of like the best genetic material for the offspring. And then it can also facilitate nepotism, which is just preferential treatment of related members in a group. So if you know who your siblings are, you'll treat them better than other individuals that you aren't related to. So a really good example of this is with vampire bats. So vampire bats go out every night and feed on the blood of animals, right? And if they don't do that, then they will die. So studies have shown that sometimes if a bat can't make it out, then they obviously don't get that meal, so they're probably gonna die. Other bats that are related to that bat that hasn't gotten the meal will go out and feed and regurgitate that blood for that animal. So that's kind of like nepotism, good nepotism example. So these recognition mechanisms really facilitate the kin selection theory, which is kind of like an alternate theory to the natural selection theory, where instead of survival of the fittest, every man for himself, it's okay, kind of every family for itself. So all the organisms that are related to each other are going to work with each other to make sure that they're all happy and healthy and going to survive, to make sure that their family's genetics is passed on, regardless of whether the individual's genetics are passed on. So that's kind of like a big differential note between natural selection and kin selection. So natural selection, it's every individual's genetics the goal of every organism is to pass on each individual's genetics, and then kin selection, it's every family or group's genetics. So that explains the eusocial behavior of insects, or like with the bats, vampire bats, and the blood meals. It's because even though there is a slight cost to the altruistic behavior of these organisms, they are still in a way preserving their genetics, just not individually, it's their family's genetics. So I hope that this was interesting and the peacocks were not too loud, that you learned a little something about kin recognition mechanisms and the kin selection theory.